Captain, we are now entering the Bermuda Triangle, 10 miles until destination.
Right, set navigation and secure everything. We are now entering the fog.
It's getting pretty rocky.
If my calculations are correct, we should be out of this fog in about 3 minutes.
The compass seems to be malfunctioning. What's going on?
Go check the navigation controls. If we keep flying forward, we should be out in a little over 2.5 minutes.
Nation spotted. We are now over Miami.
Go check the clocks. How long were we in there?
20 seconds, ma'am.
Impossible! That means we traveled 100 miles in 3 minutes.
It seems so, Captain. Space warps. These types of warps create a fold in the fabric of spacetime. Creating warps in spacetime may make it possible to travel a much greater distance in a shorter amount of time, possibly even faster than light. Objects with mass engrave pockets into the fabric of spacetime around a planet. In other words, gravity is the geometry of spacetime. However, one problem is that space warps take a lot of energy if we were to use them. So what exactly are these warps, and how do they work?
Well, there is a distinction between man-made space warps and natural space warps. Man-made space warps are the fictional warps mentioned in movies like Star Trek that propel your spaceship forward faster than the speed of light. However, natural space warps aren't really space warps at all. An occurrence of natural space warps is when the space around the object with mass bends around it, forming a sort of pocket in the fabric of spacetime. According to Einstein, time and space are woven together, creating the fabric of spacetime. The fabric of spacetime is not one smooth surface like the lacy linen that lines your kitchen table. All throughout it, there are little indentations of gravity surrounding the different stars and planets. A natural space warp is a mass that pulls the space around it in all directions. Einstein's general theory of relativity gives us a better understanding of these natural warps. The general theory establishes the connection between gravity and special relativity. This gives a collective description of gravity being a geometric shape of spacetime. Spacetime is any mathematical model that combines space and time into a single sequence, space being represented in one-dimensional, two-dimensional, and three-dimensional, while time is four-dimensional. For example, if you were to put a bowling ball in the center of a mattress, you would see an indentation in the mattress centering around the bowling ball. This shows gravity. It's the same thing in space. The bowling ball represents the planets, and the mattress it rests on represents the fabric of spacetime. These warps pull down the space around mass naturally. Warps like these already exist in our universe. But what about these fictional warps that allow us to travel faster than the speed of light?
A fictional space warp is an achievement mankind hopes to accomplish one day. This will allow us to move faster than the speed of light, which contradicts Einstein's special theory of relativity. The special theory states that light will always travel at one speed no matter how it is observed, which means nothing can surpass it. The famous warp speed mentioned in numerous sci-fi movies is showing how to create other man-made warps that, in essence, bring two objects closer together. The man-made warp folds space-time, making the distances curved. For example, let's say we have two planets. You are trying to get from one planet to the other, but the trip will take too long. If space warps were to exist, then they could bend space-time, folding it over, creating a shorter distance. It's like if you had a mattress with one bowling ball at one end and another at the other. Then a mass that is heavier than the both of them is placed in the middle. Both the bowling balls will gravitate towards the large mass, bringing them closer together.
Star Trek and Doctor Who, two of the most famous science fiction franchises, both have fictional space warps and hyperdrive. But we all know CGI and special effects are what gives these movies the ability to defy the laws of physics. Pure fiction. But perhaps one day fiction will become reality. Like Stephen Hawking once said, today's science fiction is often tomorrow's science fact.